For as long as we have looked up at the stars, we have looked up and wondered, how much time does the universe have left? We measure our lives in heartbeats, in sunrises, in the turning of the seasons. Even the existence of the human species is just a blip compared to the Earth at 4.5 billion years and counting, and the universe at 13.8 billion years. Our planet spins, a celestial clock ticking away in the vastness of space. But does this clock have an end? When we now ask, will time itself ever end? This is a question that pushes the very limits of our understanding, a journey into the deepest future imaginable. To answer it, we must travel billions, trillions, and even googles of years forward to witness the final act of the cosmos. First, let's understand time as we experience it. We think of it as a river, flowing ever forward. This flow is governed by a fundamental law of physics, the second law of thermodynamics. It states that entropy, a measure of disorder, always increases in an isolated system. A scrambled egg won't unscramble. A broken glass won't reassemble itself. This forward march of disorder is what gives time its arrow. As long as things can become more disordered, time moves forward. So the real question is, will the universe ever run out of ways to become more disordered? Our journey begins close to home. In about 1 billion years, the sun's steady increase in brightness will have a catastrophic effect on Earth. Its energy output will be about 10% higher than it is today. This might not sound like much, but it's enough to trigger a runaway greenhouse effect. Our planet's oceans will begin to boil away, enveloping the world in a thick, suffocating steam. The blue marble will become a scorched, lifeless rock. Our time here will have long since ended, but the sun is just getting started. In about 5 billion years, it will exhaust the hydrogen fuel in its core and begin to swell, transforming into a red giant. Its outer layers will expand, engulfing Mercury, Venus, and possibly even our own barren Earth. The heart of our solar system, the star that gave us life, will become its destroyer. The familiar planets and moons will be vaporized, their atoms scattered into the expanding stellar envelope. It will be a funeral pyre for our entire celestial neighborhood. Even after this cosmic drama, the universe will still be bursting with light and energy. Trillions upon trillions of stars will continue to shine across countless galaxies. But they too are on a clock. The era of star formation, the stelliferous era, will eventually come to an end. The vast clouds of gas and dust needed to forge new stars will be depleted. One by one, over unimaginable timescales, the existing stars will burn through their fuel. The last, smallest red dwarf stars, the most frugal burners of the cosmos, will finally flicker and die after trillions of years. Imagine it. The last star in the universe fades to black. What follows is a darkness unlike any we can conceive. The universe becomes a silent, cold graveyard of stellar remnants. Black holes, neutron stars, and white dwarfs. The age of stars is over. All that remains is the faint, fading glow of these cosmic corpses. The sky, once a tapestry of brilliant lights, will be an eternal, empty void. The universe will be almost entirely dark. But even in this profound darkness, the arrow of time continues. Why? Because matter itself still exists. Protons, the building blocks of atomic nuclei, are thought to be incredibly stable, but perhaps not infinitely so. Some theories predict that over timescales far longer than the age of the universe, so far a one, with 36 zeros after it, years or more protons will decay. This process is impossibly slow. If you could watch a single atom, you would wait for an eternity and see nothing. But across the entire universe, with its countless atoms, this decay becomes an inevitability. Every rock, every dead star, every planetoid will slowly, atom by atom, dissolve into a whisper of radiation and elementary particles. The very concept of objects will cease to exist. All the intricate structures that the universe spent eons building will come undone, returning to a simple soup of fundamental particles. Matter, as we know it, will be gone. Only the most mysterious objects will remain, black holes. For a time, they will be the kings of this empty cosmos. But even they are not eternal. Stephen Hawking discovered that black holes slowly evaporate through a process now known as Hawking radiation. It's an excruciatingly slow process. A solar mass black hole would take a 1 with 67 zeros years to evaporate. The supermassive black holes at the centers of galaxies will take far longer, up to a googol years, a 1 followed by 100 zeros. But they will evaporate. One by one, even these gravitational titans will radiate away their mass, ending their reign in a final faint flash of light. With the death of the last black hole, the universe will enter its final state. This is the era of heat death. The universe will be a vast, cold, and almost perfectly uniform sea of photons, neutrinos, and other stray particles, all spread thinly across an ever-expanding space. The temperature will approach absolute zero. There will be no gradients, no differences in energy, no potential for anything to happen. Entropy will have reached its maximum possible value. There are no more eggs to scramble, no more glasses to break. The universe is in a state of perfect, permanent equilibrium. And in this state, does time have meaning? If no event can ever happen again, has the river of time finally reached the sea? With no change possible, the forward march of entropy, the very arrow of time, comes to a halt. The clock of the cosmos freezes. Time, as we understand it, will effectively end. There is no more next. There is only a static, silent, eternal now. This is the ultimate fate of everything. A future of cold, empty, timeless darkness. It's a stark and sobering conclusion. But it is not our conclusion. This end is trillions upon trillions of years away, a number so vast it's practically indistinguishable from infinity. We are living in the first brilliant second of cosmic dawn. Look around. We are not in a cold, empty void. We are here, now, in an era of unbelievable richness. The universe is still young, vibrant, and filled with the fire of creation. Stars are being born. Galaxies are colliding. Planets are forming. And on this planet, life is thriving. Every single morning, our star rises, flooding our world with energy. It is a daily miracle we so often take for granted. This light, this warmth, is the engine of our world. It fuels the plants that create the air we breathe.
It's so
It drives the weather that fills
Let's
our
take a
rivers.
picture here.
And it illuminates the faces of the people we love. This is the stelliferous era. The odds of our existence, right here, right now, are so astronomically small as to be a miracle. In the face of that ultimate cold silence, what truly matters? The only answer is what is here now. The warmth of a hand in yours, the sound of laughter, the pursuit of knowledge,
What do you think,
the
my love?
creation of art,
It's beautiful,
the act
as
of
always.
kindness. These are the things that fill our brief, precious moment in the light with meaning. The cosmic story will one day end in darkness, but our story, the human story, is written in the brilliant light of today. So will time ever end? Yes, but not yet. And while we are here, in this dazzling, improbable present, let's make it count. Let's appreciate the sunrise. Let's build and learn and love. Let's be grateful for every tick of the clock, for every moment we have under our magnificent, life-giving star. Because for us, time is not ending. It's happening. Thank you for watching. If this journey through time made you think, consider subscribing for more explorations of our amazing universe.